take out our highlighter. We're going to learn some new words. We're going to look at reciprocal functions. We're going to learn a new word, asymptote. This graph has a horizontal asymptote at 0 and a vertical asymptote at the non-permissible value. So x cannot equal 1. We're going to use the abbreviation of NPV for a non-permissible value. On the graph, we show that with a red dotted line at x equals 1 to say your graph can never go through that vertical asymptote. So notice how I'm gonna draw over top of this graph in blue. Notice how the graph gets closer and closer to that vertical asymptote and never touch it. It also gets closer and closer to the horizontal asymptote, which I can label at y equals 0. So what is happening here? Yes? An asymptote is a line that a graph gets closer and closer to, but doesn't touch it as it gets closer to it.
It's like when you're walking towards the wall, you get halfway there.
Right, that's like approaching an asymptote. Okay? Now, look at the green line. The green line is y equals x minus 1. And I'm going to label a couple of points on there. For example, on the green line here, I have 4, 3. All that happens on a reciprocal function is that now the x minus 1's on the bottom. So if I plugged in 4, does it make sense that I would get 3 on the bottom of that fraction? So if I had 3 originally, I have 1 over 3 now. Right? When I had 0, an x-intercept, or 0 originally for my y value, if I do 1 over 0, I have a non-permissible value. That's why I have a vertical asymptote at that point. The reason we have a horizontal asymptote is if I keep going to the right. So for example, on this graph, I could plug in 7 just for you, and I would get 6. And then if I did the reciprocal of that on the blue one, I would have 7 comma 1 over 6. Can you see that I'm even closer to y equals 0 at that point? And somewhere along here, I'm going to have the point 100 comma 99. And then I would have on my blue graph 100 comma 1 over 99. All that's happening is our y values are now on the bottom because we have 1 over the graph we had originally. And as the y values get bigger and bigger and bigger, and if you did 1 over a bigger and bigger number, you get closer and closer to 0. Question?
I don't really understand what our asymptotes are like really measuring though. Because we have our line,
Yeah?
and then we have 2 asymptotes.
Mm-hmm.
What are those asymptotes telling us?
The asymptotes are telling us that once I'll show you an example. Let's say you want to graph 1 over 2x plus 6. So I go and I say 1, 2, 3, 4, 5, 6. I know that my original graph has the point 0, 6. I know that the x-intercept, like I'm going to graph y equals 2x plus 6 first. And I know that it has an x-intercept at -3, and it's a straight line that looks like this. Okay? And I'm going to graph this in green. The first thing I'm going to do is draw my asymptotes. With a reciprocal graph, I know that at the x-intercept here, that now x equals -3 is a non-permissible value. It would cause me to divide by 0. Okay? In the reciprocal graphs that we do this year, every single one will have a horizontal asymptote at y equals 0. Next year in grade 12, some won't. But anytime your original graph goes up or down forever, right? The range would be to infinity. That means the y values keep getting bigger and bigger and bigger, either positive numbers or bigger and bigger and bigger negative numbers. And if I would do 1 over 1,000, that's really close to 0.
Mr. Chiang, you made a mistake. Negative numbers get smaller.
Bigger and bigger negative numbers.
No, they get
So like,
they get smaller. Like -2 is bigger than, I mean smaller than -1.
fair enough. Okay. But if I did -1,000,000 and I did 1 over -1,000,000, it would be really close to 0. So the horizontal asymptote is showing that if the original graph goes off to positive infinity or to negative infinity, when you do 1 over that, you get really close to 0. So I'm going to start by drawing both of those asymptotes because they give me an idea. I know my graph is going to go towards those values but not touch them. Then I take points that were on my graph, like I had 0,6, so I know that I'm going to have 0,1 over 6 on my reciprocal. A really nice point to find is where the y value is 1. I don't even need to know where the x value is. Because what do I do if I have 1 for my y value?
1 over 1.
1 over 1 is going to be identical. That's the only point where y is, there we go, green. And the only point where y is positive where they're the same, and the only point where y is negative where they're going to be the same is at -1. Does that make sense? Because 1 over -1 would be the same. I mean, I can find another point on my blue graph. What would happen if you plugged in -5? Can you see that you would get -10 plus 6, you would get -4? So that means on my green graph, I'd have -5, -1 over 4. Technically, as soon as you find one point, you have enough information to draw your graphs towards your asymptotes and you're done. So the asymptotes are really helpful for drawing the shape. They don't measure something, but they help us draw the shape of the graph after. In fact, it's enough. As soon as you have one point, you know it's going to swoop towards those asymptotes. And you're going to be able to draw it and graph it easily. Now, our new graph looks totally different than what our line looked like to begin with, which makes these graphs a little bit tricky, but not crazy. Okay? So I'm going to add the graph to this example one. Determine the equation of the vertical asymptote. Well, if I first graphed 4x minus 3, if I was graphing a line, I would start with my y-intercept and label it 0, minus 3. I would use my slope and count up 4 over 1 and label 1, comma 1. And I would plug in 0 for y and solve I plug in 0 for y and solve for x to find my x-intercept. My line looks like this. And if you wanted to, you could go up 4 over 1 again and get 2 comma 5. No problem. You could plug values in using a table of values to find other values. Where are we going to have our vertical asymptote? We're going to have our vertical asymptote at the same place that we have our x-intercept. So labeling that x-intercept, super important. Like I said, all of these graphs will have a horizontal asymptote at y equals 0. What's going to happen to 1, 1? It's going to change to 1, 1 over 1, which is still 1, 1. What's going to happen to 2, 5? It's going to change to 2, 1 over 5. What's going to happen to 0, -3? It's going to become 0, 1 over -3. Do we have enough points? Absolutely. To draw towards those asymptotes? This is our new graph. So you can circle questions 4 and 5.